Hello, my name is Brandon Carl. This is my Minesweeper app that I've made in C++ over the past 3 to 4 weeks. So I'm going to run through the code on the left and the game on the right here. So first, when we go into main, the first thing that we do is reset this. This is in case the player won and then chooses to restart their game from inside the game itself. This just makes sure everything runs right. Then we run difficulty selection, which prompts the player right here. Welcome to Minesweeper. Please choose 1, 2, or 3 for easy, medium, and hard. And then it reminds them of what they selected. So if I choose easy, I do 1 and enter. It says you've selected easy. There's 10 mines. This is a debug statement. Make sure the mines are placed. And then another debug statement. And grid is 5 by 5, 0 to 4. And grid is generated. This dotted line is just to help separate the grid from everything else, especially when reprinting it. So then the player needs to, so then the program goes into build grid where it sets values, it assigns the grids, which is right here in main. Spawn mines here is obviously the function that spawns the mines. It takes the it takes the value bomb count, which is unique for each difficulty. So 1 is easy, 2 is medium, 3 is hard. Sets that dynamic variable. Does a couple of other things to make sure it runs right. Assigning the grid array. So this 2D array is defined, so it knows how much space it needs. I have easy, medium, and hard constants defined up on the top as globals. And then we run spawn mines with the value of the bombs for each one, and it places all those, does its thing. Here's spawn mines right here. Randomizes the position, goes through the entire grid. This variable here, current mines, tracks how many it's actually planted. So once current mines equals bomb count, it's planted all the mines it needs for that difficulty, and it breaks out, says how many mines have been placed. So right here, 10 mines placed. And then it jumps back into build grid down below all the difficulty variables, creates the grid. Revealed IJ is the value the player actually sees, so it starts as a space, which you can see right here. There's nothing in any of these spaces. It sets the win condition here. Win condition variable, I tried to make this work with a variable, but for some reason it would only work as hard-coded. So this actually doesn't do anything right now, but it doesn't break anything, so this is what I was trying to do that didn't actually work. But this is the basic logic of how you win. So the grid size times the grid size is, in this case, 5 times 5. That just means all 25 spaces on this board, minus the bomb count, which on easy is 10, so there's 15 clear spots and 10 bombs. Once you've discovered all 15 safe zones, or clear spots, which would be the 25 minus the 10 of the bomb count, then you win. And then after build grid is complete, it prints this statement, which is right here, and then it goes into build grid, which actually prints the board, or it goes into printing board, which is right here. So again, this is where I had to hard code it right here, which is not ideal, but for some odd reason it wouldn't work with the variables that I had given it, and I didn't have time to debug that completely, but it does work with these set variables. It does dynamically change with each difficulty, easy, medium, hard. Reprinting, so that's if after the first round it does that, it prints and reprints the grid. So it prints it the first time, and then it prints it again after the players entered their inputs. So the next step here, which this game has been kind of sitting waiting for me to do, is to actually enter coordinates to select a spot. So I have it set up to take row and column. So you take a row value first and a column value second. So we can go in here, and then these statements here, these check if you've entered something that's above that range. So if I enter something that's above 5, so if I go back to the game, I'll do 0, enter, 0, enter, and we can see a 0 pops up, meaning that there's no bombs in any of these spaces around it, and it prints down here. We found one of the safe zones, and there's 15 remaining. So then you just loop that process as much as you need until you've either hit a mine or completed. So we'll see how far I can get without dying. Okay. Jump over to 4-4. Oh, and I hit a mine. Okay. So when you've hit a mine, let's try to find that in the code here. Trying to remember where that's at. Right here. So if the player hits a mine, if grid XY, so the X and Y here are the inputted values. So the grid array is the grid that holds all the actual values of the spots that are hidden behind the revealed array. The revealed array holds all these things that show up, and then grid, once you've entered a coordinate for this square, it reveals the value that's actually grid XY instead of revealed XY. So when you do that, it clears the screen. So that's why I can't scroll up anymore. All this is gone. And then we double space down here. We have a full reprint of the grid that reveals all of the mines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is the one that killed me down here, 4, 4. So when you hit that, it reveals all these. It doesn't reveal the other spots because you don't need to. You've already lost. But it reveals all the mines. And then down here, choose replay and quit. So you either enter 1 or 2. So we'll replay. Boop. And then it just goes back and runs the whole thing again. The way replaying works is there's a switch statement. So I have a character A that just holds the input 1 or 2. Doesn't need to be anything complex. The prompt here, replay is 1, quit is 2. The switch statement has two cases and a default. Case 1, so if they enter 1, it sets finish back to 0, which I just need to do to make sure it runs right, because whenever they win or lose, it sets finished equal to 1. Right here, finished equal to 1, and finished equal to 1, that just lets the game know they've won. So if finished equaled 1, you play replay. That's just an easy way to have the same restart sequence for whether they've won or lost. So then clears the screen. So that gets rid of all the you lost, you hit a mine stuff, and goes back to this. It runs main again, so it starts back at difficulty selection and then breaks out of the loop. Case 2, I don't even really need this whole system clear here, because all it does is break out of this. It finishes what's left of main, which is the return 0, and the application closes. And then coot if you've entered the wrong thing. The default state, so if you enter anything other than 1 or 2, it just forces you to select again. It runs replay again. I probably should have gone over print and reprint grid earlier, so I'll just go medium this time. So this is where it's checking after the player's entered an input, so grid XY, if the spot that they've entered, the spot that they've inputted inside the grid array is a 0. If it's totally clear, then the revealed grid is going to print 0. Otherwise, it's going to print the number of mines that's around it, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 5, 6, 7, 8. And then when they get to the last one, so revealed is a string array, as opposed to grid, which is an int array, which you can see here. The reason I did that is because then you can print mine as M instead of doing it as 0 or 9, because 9s look a lot like 0s in standard console font over here, so it's easier to see it as an M. These spaces just make sure column is spaced right and row is spaced in the right place. Right here is put in the right place, so as it's running through here, when it gets to I equal to 2, or sorry, j equal to 2 in this loop, no, it is I. When I is equal to 2 in this loop, as it's going down, it, instead of just printing this, the normal empty spaces value, it prints row empty space value. I could put this at any number, but I thought 2 was fairly decent. It's closer to the top. It's easier to see both of these at the same time if they're both near each other. Up here is just printing these headings. So it's a space, a line, the actual value, a line, and space. That just keeps them all spaced out. They do all line up with the center because of those spaces, because those are the same amount of spaces as there are here. There's a space on this side, space on this side, so they're all evenly spaced out. That's just making it look better for people. This one prints the actual value that the player is going to see as it goes through this entire grid. So it prints a line on the left, right here, space, value, space, and then it prints the line from the next one as it's going through the loop. And then when those are all done, it prints another line at the end right here. Jumps down to the next line, prints this row divider, which is a dynamic variable that I set up that has a different sized bar for each difficulty so that it lines up perfectly. It starts at the beginning of the grid, ends at the end. Again, just making it look as best as I can. There's a different one for easy, medium, and hard. They all work perfectly. And then we do a double space down to the next line. Since these are all underscores, I had to do a double space to make sure the spacing actually looked right on both sides of this line so it wasn't too close to the bottom or the top of them. So that basically covers all of the code. Oh, this part right here is the last important part. So this is how we manage tracking values around it. So if I enter please no mine. Okay, so this 3 right here that I've entered, when I enter a value, it runs through this entire loop here. Or sorry, this entire loop, which sets so mine tracker here is tracking how many mines are in this 8 grid square around the inputted value. It runs through them and checks, is there a mine there? And if there's a mine there, it makes this value go up by 1. So down below this loop, we set the square that they inputted, the coordinate they inputted, to the value of mine tracker, which is set by how many bombs are around it. So if the selected spot is a 9, you're just going to break out because it's a bomb, and that's handled by a totally different part of the function. It's just going to skip all this stuff. So if the top one, so is that top left up here, top middle, top right, then middle left, middle right, there's no middle because that's the inputted value right there. Bottom, left, middle, right. So it goes through that whole process, I guess starting up here, do that. If there's a bomb there, it adds 1 to mine tracker, and then at the end of this loop, when the loop finishes, when it's gone through all those spots, if the one they entered isn't a mine, then it sets the coordinate, or the printed value of the coordinate they selected as mine tracker. So if I have a mine in all these spots, it will be 1, 2, 3, 4, 5, 6, 7, 8, and there will be an 8 printed there. So right now there's 3, so there's 3 in 3 of these 8 spaces. Then it resets it so that the next time I select one, it doesn't add 3 to that value. And then, of course, if the place you've selected isn't a bomb, it adds to the safe zones that you've found. Once that value gets up to 15, you win. Printing the values for safe zones after each one. Yeah, that's pretty much all the important code there. I do believe that's all of it, so I'm just going to, here's an example. There's the custom row divider length for easy, medium, and hard. They're all different lengths. Yeah, okay, so I'm just going to run through medium and hard and see how far I can get to show you that all these things work. And I hit a mine right away. Okay, so I'll show you quick here. If I hit 2, it just boop, closes it. So I'll open that back up. I'll try medium one more time, and then we'll try hard and try not to die immediately. Boop. Okay, 2, 1. Okay, so either of those, either that one or that one is probably a bomb. Well, it is a bomb because that one's 1. So let's try 5, 3, doing row, then column. So row 5, 5, column 3. Okay, I'm going to take a gamble and probably blow up. Going for this spot right here. Boop. Okay. So it's that one. That one's a bomb. Now good old 0, 0, which is almost always a bomb. Yeah, I was wrong. Okay. So there should be, I gotta remember, I think it was 15 bombs for medium. So we can count these up, make sure it's the right value. Yeah, 15 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I will replay and run hard. I want to win so I can show you the win condition, but I don't know if I can do it quickly without cheating. Certainly not on hard. This is going to take forever if I try and do it, because there's 39 safe areas, because there's, I think it was 20 bombs? 25 bombs, yeah. Boy. There's 5 around that one, okay. And there's a mine. I did 4, that's a mine. Don't really need to count these, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay. Let's see if I can... I do have cheat code in here for printing a little grid that tells me where all the values are, just so I can show the winning value. Okay, code is ambiguous. I don't know why it always tells me that. It still runs perfectly fine. So we'll run value 1, and that will print this little handy little testing grid up here that shows me what's a bomb, which is a 9, and what's a 0. So this grid just prints without any fancy formatting grid IJ. So the actual values that are hidden behind these spots, which is all these 0s, clear values, and 9s, unclear values. So I'll just run through this grid. 0, 1. Okay, and that's the last one. This spot right here, this one right here, 1, 3, boop, and you've won! This is kind of an unceremonious page. There's easily more things I could do with this to make it more fun, but it works. Functionality is all good, and if we replay, it works the same with my little cheat grid. Boop. And good old friend 0, 0, which is 99% of the time, and mine. Boom! And quit. Okay, thank you for watching, everybody. I'm going to comment this part out. Edit advanced, comment out, so I don't keep cheating. Thank you for watching, and I hope you enjoyed my Minesweeper game. Thank you.